Okay, laboratory instructions for today. This is the electroscopes lab number 14. You got a sheet like this yesterday. If you don't have one, there should be some up on the front lectern. We have three basic parts to this one. You're going to be using the electroscopes themselves, and I did show you how this worked a little bit yesterday if you were here in class to see it. And then the second is going to be pith ball electroscope. So these two are graphite-coated styrofoam ball, and those things then can assume charge because graphite is actually a nice conductor. And then the third thing is called an electrophorus. This is an old technology piece. Not that styrofoam cups existed back in the day. It used to have a wooden handle with a metal plate, and we have two dissimilar metals. So we have an aluminum pie plate, and we have a styrofoam plate. Okay, more on that in a minute. First step then, electroscope. Using the triboelectric series, found in the front here, also found in your text, having various kinds of interactions with materials will allow you to decide what type of charge you might assume on each particular item. So I'm going to try PVC, and I'm going to try a rabbit fur or cat fur in this case. If you are allergic, please note that these are animal furs, and they've been treated. Chemical or supply company, I think, has taken these. They are probably older than me, maybe even some of the materials there. But if you look at the PVC pipe and then you look at the rabbit fur, comparing those on the triboelectric series, we're going to find that the PVC pipe is towards the bottom, the rabbit fur is towards the top. So if you look at that on your sheet for a second, you can establish now what should have what charge. So because the PVC pipe is lower on the triboelectric series, it's more towards the negative end. It's interacting with rabbit fur, which is more on the positive end. We would expect then that the PVC pipe should assume a negative charge when it's charged by friction of the fur. So just you make contact, and vigorous twisting is all you need, and that should then assume a charge on the end of that PVC pipe. We can test it against an electroscope. And so there's our electroscope as we saw yesterday. We can put this near the needle or near the conducting sphere. There I touched it. I probably don't want to do that at first because you want to experience both of these things, induction and conduction charging. So remember that you can ground yourself to a metal object somewhere in the room, then you can ground the electroscope. That's simply giving a path for the charge to follow if there's excess. Now I bring the charged pipe nearby that sphere, and I can see that there's deflection down below in that needle. If you were to try to quantify it, you might count the number of black strips that the needle is deflected. You need to get down at eye level to see that. But that's charging by induction. Okay. If I make physical contact with it, I deposit charge, and I should see that then the needle stays apart. And again, you can sort of get an idea based upon how far it is. Additional charge you can bring to the electroscope, and you see the effects. Now, if I charged an object with positive charge, now I want to try glass, maybe, and silk. So looking at the chart here, glass is there, silk is here. So silk is below glass, therefore it's going to assume negative, and the positive charge then should be assumed by the glass rod. Be careful. These glass rods, if they fall, they will break. To find some silk, I've got various things here. There's some of this cloth. This particular green cloth, I can verify that's silk. I brought that in from past laboratories. And so now we should assume a positive charge on this glass rod. If I bring it close to the electroscope, look what happens. See? Because it's still deposited charge there before, it's negatively charged. We can prove it's negatively by bringing something opposite nearby. So by induction, we can see we're removing some of the charge from the needle, and the needle is falling. If I touch it now, okay, I've canceled it out, right? And so then you can continue that experimentation back and forth. This is an ebonite rod, plastic. It's a rubber rod. I find that the PVC pipes work better. There are also some acetate strips or plastic strips somewhere in this box. You can try various things to see what you can accomplish for charge. So that is the electroscope. So you'll try those. The other one's the pith ball. The pith ball electroscope, basically we've got these two spheres. They start out neutrally charged, And now if you bring a charged object nearby, we want to see what's going to happen. And so what we want to do then is we'll charge up, I'll do it before, the rabbit fur and the PVC pipe. Rabbit fur and PVC pipe, what should be the charges? Use your triboelectric series. Okay, so doing that, watch what happens when I bring this nearby. You're going to watch closely. Notice at first that pith ball doesn't do anything, and then it starts to approach. Interesting. Once it touches, if the pith balls behave properly, then you should notice another change. And I'm going to leave that for the experiment to see if you can do it and figure it out. But there should be more than just what you saw in the combination here with those two in terms of how they respond to one another. So again, if you're bringing it close, you're charging by induction. We're not touching. We're getting close. Okay? We're getting close, but not touching. Then when you touch it, interesting to see what can happen. Do that slowly. Take it procedurally, step by step, to see what you can observe. Okay, the last is the electrophorus then. And the electrophorus, the foam cup on the top, these are in a box on the floor. That's an insulator. The metal then is a conductor. And we have another insulator. So two dissimilar materials. In order to charge it up, there should be in this box some wool rags, okay, old sock. And all you need to do is once, you should only need to do this once. You rub the wool against this styrofoam, and you're going to set up a charge on it. Okay? Then, with the electrophorus, ground it, touch it to the plate, ground it, and separate it, and see what happens. Try different combinations of things. Try the electroscope, try the pith ball. Now I just felt a little shock to my hand there, so I'm probably not going to see what I'm going to expect. But you can recharge them simply by putting them on the plate. Charge. Don't touch the plate when you're removing it. You should feel a little stickiness. That stickiness should give you an indication of charge. And if I bring this close, look at that. There's something going on there, okay? So you should be able to make some observations based on your use of electroscope. Again, charge the plate once, discharge the pan, put it on top, ground it, hold the bottom plate and separate by the two insulators. And now you've got basically a battery. Interesting. See how many times you can do it, back and forth. It's not a competition though. I'm hoping that's going to be helpful for today's lab.